Today, we'll compare a speed of generation for OpenChat 7 billion model by running it on 3 different single-board computers: Raspberry Pi 4, Raspberry Pi 5 and NVIDIA Jetson Xavier. And we'll see if that computers are suitable for some robotics application when our LLM could be decision brain of our robot. And also I'm very interested about performance of the OpenChat model in comparison, for example, to Zephyr that you might see in our previous videos. First of all, we test run of our model on the Raspberry Pi 4B with 8GB of RAM. To do this, let's start with installing Dataplicity into our device. It is not necessary step, but it's really helpful. Dataplicity allows to connect to our device from everywhere without worrying to find local IP addresses, especially when we're switching between different networks. And also it's helpful when we, for example, connecting our device to the mobile network, what could happen very often in case of our mobile robots. So to install it, let's provide our email in the main page of dataplicity.com, and after let's copy code that appeared here and let's paste to the local terminal of our device. That's all we need to do. After that, our device will appear in the main page of Dataplicity. Now we can connect it without worrying about any SSH credentials. Let's switch our user to Pi. Next, we need to install Ollama, and Ollama is a great way to run our model on Raspberry Pi, but not only, basically on every device, every computer. Let's go to ollama.com and let's copy installation code for Linux. Let's hit on our terminal and Ollama will be installed. The Ollama is here. Let's download and install our model. And this time I want to use OpenChat model, which is for today's day is one of the most intelligent 7B models out there. So to run newest version of OpenChat in default for Ollama 4B quantization, let's just run command Ollama run OpenChat. It will take for you some time to download it because it weighs more than 4 GB. I have it already downloaded, so I need just start. In meanwhile, I prepared the prompt for our tests. It's very similar prompt to one of our previous videos about Mars rover, and this is also simulating Mars rover and ask model to decide about best direction to go. First, we're providing data from cameras, where at front we have inaccessible rocks, at right clear space, at left deep crater, and rear we have dust storm. After that, we're providing instruction. We're asking model to act as Mars rover and explaining him his task, and asking to return our response in JSON format, because ideally in case of our robot we further will need to process our response programmatically. And in this JSON, first of all, we ask it to think about possible directions, make step-by-step reasoning about it, which basically really helps to improve quality of responses and also make our reasoning process very verbose. And just after that, we provide in direction field, where model actually need to point the proper direction. So let's copy it and let's paste into our terminal. I'm hitting enter and measuring time it needs to generate a response. First of all, it loads our model to RAM, and after about 2 minutes, it finally starts to generate text. Based on the sensor data, the best direction is to go is as follows. The front is inaccessible due to rocks, so we cannot move forward. The right side has a clear space, which indicates there are no obstacles or hazards preventing movement in that direction. The left side has a deep crater, which would be difficult and potentially unsafe to navigate through. The rear is affected by dust storm, which could affect the rover ability to drive and may also hide potential hazard. Therefore, the best direction is to go is right. And we can see our model provides very good reasoning and chooses appropriate direction, which is right. To generate that response, our model needed 5 minutes and 25 seconds. Well, it could be a long time in some field conditions when model need to decide fast. But what we can do here? Let's run our model one more time. Why? Basically, now we tried our model to run from cold start. It first needed to be loaded into the RAM, and after that it just started to generate a response. Now our model is already loaded, so if we will run it one more time, let's see if it will run faster. Let's hit enter, and we can see after hot start, our model started to respond almost immediately. This time again it provided a good reasoning and response, and time it needed to respond was only 2 minutes and 6 seconds. One of the reasons that time is much shorter is that our reasoning is also shorter than previously, but I think main reason here is because model was already loaded into RAM, so it don't need to spend that 2 minutes as previously to load it first, but just started generate response. I want to also run it 2 more times to calculate medium time of response for a hot start. And after 3 hot runs, our medium time of response for hot runs is 2 minutes and 51 seconds. It's already much less than in case of cold run, and my conclusion here is that running our model when it's already preloaded into RAM, in case of Raspberry Pi 4B, could save us 2 minutes of response generation. So there's results for Raspberry Pi 4B 8GB of RAM, and now let's proceed to next computer, which is Raspberry Pi 5 with also 8GB of RAM. Let's do again a llama run open chat and let's paste the same prompt. In case of Raspberry Pi 5, it needs a little bit more than 1 minute, about 1 minute 5 seconds, to load our model into the RAM. After that, it started to generate a response, which is, as we can even visually see, is generated much faster than in the case of 4B. Again, we can see that our response has amazing reasoning and proper answer, which is really delights me. Because as I remember our previous experiments in previous videos with Zephyr 7B, that responses, especially with normal not fine-tuned model, was so. Sometimes they were good, but sometimes they were really random and strange. But here I can see for every time very good decision reasoning and proper direction is chosen. And in case of cold start, our time of generation is 2 minutes and 17 seconds. It's around 2.5 times faster than in the case of Raspberry Pi 4B. Let's try for a hot start. For a first hot start, it takes exactly 1 minute to generate. This, by the way, we have first example of our response when our response generated bad. It like 7th or 8th try when finally we received bad response, because we can see that our reasoning is really short, it's basically not reasoning at all, and based on the bad reasoning our model is just choosing a random direction and also generated JSON of bad structure. So that's why proper reasoning is very important to generate good answer. Okay, so let's not count the time, let's run it again. And for next times our generation was even faster, and medium time for Raspberry Pi 5 was only 0 minutes and 53 seconds. So we can see that Raspberry Pi 5 completely beats Raspberry Pi 4 in speed of generation for 7B model. It's 2.5 times faster in case of cold start and 3 times faster in case of hot start. And that time, 0.53 seconds, it's already much more acceptable time for robot decision generation. Still, it's not real time, but in case of some robots, you already can use Raspberry Pi 5 to be brain of it and be able to generate our response in some appropriate time. Also remember that we're using here not fine-tuned version of our open chat, so I'm pretty sure when you appropriately fine-tune it, you will be able to achieve even smaller times of generation because of just no need to write all that instruction. By the way, I previously prepared deep dive into how to fine-tune our model, so if you're interested into how to do it line by line, please check out our previous videos. And our last test we'll do on NVIDIA Jetson Xavier with 32 GB of RAM. It has more RAM than my home GPU. So let's do the cold start first. Based on our prompt, generation on cold start on Jetson Xavier takes us 2 minutes and 26 seconds. This is similar time like it was with the Raspberry Pi 5. Let's run it again. Ta-da! Now with hot start, it started to generate immediately. First hot generation took us 1 minute and 17 seconds, but well, there was a lot of text to generate also. And medium time for Jetson Xavier is 1 minute and 6 seconds, which is a little bit more bigger than for Raspberry Pi 5. Surprisingly. Maybe because actually Llama didn't use the GPU of our Xavier to run on CPU. So my conclusion is that the Raspberry Pi 5 is suitable for running on its 7 billion parameters LLMs and make decisions for our robots. Well, it's still not doing it real time, but that time is kind of reasonable, and you can increase the time by preloading model into the RAM and also by fine-tuning the model. What about NVIDIA Jetson Xavier, why it had slower time than Raspberry Pi 5 in that experiment? Well, I think the reason is because CUDA drivers wasn't installed on it when I tried. Basically, it's all the time a lot of problems with CUDA drivers. So our LLM was actually running into the CPU of the Xavier. But when we will run it in the GPU and properly set up CUDA, I think the times will be much less because Xavier has the massive computation power. That's all for today. Thank you for attention, and write please in the commentary what do you think about that video and what you want to see in the future ones. Bye.